Hello, I'm Smita Sharma, Lindsay's Applications Engineer.
And I'm Laura Heisinga, Lindsay's Road Zipper Technical Sales Manager.
Today, we'll talk about reimagining safety and mobility for interstate work zones. We'll focus on the significance, constraints and challenges of work zone safety, as well as partnerships that have generated safety and mobility solutions. Nationwide, there is an increased focus on work zone safety due to the recent data showing decreasing work zone safety. While many articles, reports, and presentations are focusing on driver behavior and reducing distracted driving, there are other solutions available to increase work zone safety for both motorists and workers. The Pew Charitable Trust reported in October of 2020, quote, "Work zones are particularly dangerous because of daily changes in traffic patterns, narrowed right-of-way, and other construction activities, according to the Federal Highway Administration. Crews work close to moving traffic, sometimes just a few feet away," unquote. A recent study by the Associated General Contractors of America says that 9 out of 10 work zone accidents involve roadway users. Behavioral safety campaigns about dangers of speeding and distracted driving in and around work zone improve public awareness, but do not prevent physical intrusion in the work zones. It is debatable how driver distraction affects roadway safety in a world with increasing wearable and mobile technologies and significant advances in connected and autonomous vehicles. It is best to find preventative solutions to provide safety against vehicle malfunctions or driver-related factors. Positive protection alternative includes full closure with detour, static lane closure for short duration which impacts traffic mobility, and flexible lane or shoulder closure using movable or mobile barriers. In addition, automated traffic control options exist to avoid increased exposure of workers during setting up and removing of traffic control. MUTCD's guidance on positive protection is helpful for deciding between alternatives. In addition, an intrusion prevention task force is set up consisting of representatives from the American Road and Transportation Builders Association, the Associated General Contractors of America, the National Asphalt Pavement Association, leading national contractors, organized labor, and others. The coalition is tasked to provide information, best practices, improved legislation, and the ability for state DOTs to include enhanced safety measures on certain roadway construction projects. We would like to challenge you to reimagine work zone safety. Many of the project types listed here are typically completed behind static barrier, if a permanent lane closure is permitted, or using off-peak lane closures behind channelizing devices. Several factors affect the selection of work zone safety feature, including project scope and duration, traffic volume and mix, expected operation speed, risk for motorists and workers, proximity of vehicles to workers and pedestrians, roadway class, escape path or work zone access concerns, and impact on project cost and duration. Many DOTs are working to increase safety on projects where there is increased worker exposure, high ADT, a high percentage of truck traffic, and potentially night or off-peak work time frames. This photo is an example of how vehicle malfunctions can impact work zones. This was a concrete paving rehabilitation or patching project, which is often performed behind channelizing devices. This Indiana project used a movable barrier system to increase safety, which was a tremendous benefit when a semi-truck sheared off the right side wheels, causing multiple barrier impacts into the movable barrier. Without positive barrier separation, this could have resulted in worker injuries or fatalities.
The Piscataqua River Bridge in Maine is another example of work that might have been traditionally completed behind channelizing devices. The DOT wanted to decrease worker exposure in setting up and removing the lane closure, as well as separating the workers and motorists when work was taking place. Barrier was required as the bridge railing was removed during the project. Without flexible positive protection, the static barrier would be positioned on the shoulder with a non-peak channelizing device lane closure. Such workspace would have been constrained and non-productive with safety concerns due to the lack of an escape route in the channelized lane closure. Flexible positive protection provides additional safety compared to channelizing device lane closures while still allowing a non-peak nightly lane closure. Additional benefits include reduced risk of traffic queues during peak travel times compared to a static barrier lane closure, and potentially providing increased workspace when needed for contractors. Flexible barriers provide maintenance of traffic options for accelerated construction projects, reducing project staging and duration, as well as helping reduce user delay costs. The Road Zipper movable barrier system consists of unanchored 18 inches wide, 1 meter long, 32 inches tall barriers. The barriers are tested and meet the requirements of NCHRP 350 Test Level 3 and Test Level 4 and MASH Test Level 3. The barrier transfer machine transfers the barrier 10 to 16 feet in one pass at speeds up to 5 miles per hour. An Absorb 350 crash cushion is installed on the end of the barrier wall and is transferred through the machine with the barrier, eliminating an unprotected barrier end. This Indiana I-65 concrete paving rehabilitation project spanned from 2016 to 2017. In 2016, the work was completed behind plastic channelizing devices. Due to a large number of motorist intrusion into the work zone, Indiana DOT, the FHWA, American Structure Point Engineering, and E&B Paving partnered to add movable barrier for maintenance of traffic in 2017. This provided positive barrier separation between the work zone and active travel lanes, increasing safety, as well as allowing the contractor to stage their work differently to increase productivity. A static lane closure would not work for this corridor due to the high ADT and high percentage of truck traffic. This was evident as on the first night that movable barrier was deployed, the lane closure was not removed until 5 a.m. due to striping work. Between 4:30 and 5 a.m., a 4-mile queue built due to only having 2 lanes open. In subsequent days, the lane closure was opened and closed on time, providing the normal 3-lane travel pattern. Flexible positive protection provides additional safety compared to channelizing device lane closures, while still allowing a non-peak nightly lane closure. Additional benefits include reduced risk of traffic queues during peak travel times compared to a static barrier lane closure, and potentially providing increased workspace when needed for contractors. Flexible barriers provide maintenance of traffic options for accelerated construction projects, reducing project staging and duration, as well as helping reduce user delay costs. Indiana DOT has worked to increase work zone safety over the past 4 to 5 years. They have an innovative approach to maintenance of traffic that allows them to close an interstate in one direction for a 30-day time frame. If the work cannot be completed in a short full closure, then the DOT considers a static or movable barrier scenario. Barrier is used on projects with high worker exposure on corridors with high ADT and typically where there is nighttime work. For this project, the contractor used 2 short runs of barrier for their concrete patching project. This allowed them to move the barrier throughout the work zone as their patching progressed. During this project, they had a semi-truck hit and damage 50 meters of barrier, which represented approximately 1/5 the work zone. Both the contractor and Indiana DOT expressed that had the project used channelizing devices, the outcome could have been multiple worker injuries or fatalities. With barrier present, there was no safety risk for the workers on site. Since 2017, Indiana DOT has continued to use a flexible barrier for concrete patching projects. This year, there are 2 projects on I-65 using movable barrier. These projects are also being evaluated by Purdue University to explore the impact of traffic queues on safety and mobility. By using a flexible barrier instead of a static barrier option, the queuing during peak travel times is reduced. This Dallas, Texas project on the Dallas North Tollway required barrier protection as the median barrier was being removed and replaced. Barrier was also desired due to the heavy truck traffic, high ADT, and high speeds for this corridor. Static lane closures were not allowed due to mobility concerns during the daytime hours. A movable barrier was selected for maintenance of traffic as it provides barrier protection as well as the flexibility to only have lane closures during non-peak evening hours. During the peak daytime periods, the barrier is placed adjacent to the median barrier. Starting at 8 p.m., the barrier is moved to create a single or double lane closure. By 5 a.m., the barrier is returned to the shoulder to open all 4 lanes for the morning travelers.
Many projects use the road zipper for maintenance of traffic during accelerated construction. The Richmond, Virginia I-95 bridges, Boston, Massachusetts Fast 14, Boston Commonwealth Avenue, and 3 New Jersey projects all use the road zipper during accelerated bridge construction. The road zipper provided a positive barrier between bidirectional traffic, allowing for a full closure of the other bound. This gives contractors a large work area separated from traffic to complete their work in an accelerated time frame. The Minnesota DOT wanted to utilize echelon paving on Highway 494 to provide a smooth paving surface. This required one bound of the highway to be closed for weekend paving operations. The local roadways could not support detouring of all the traffic from 494, so one lane of traffic was diverted to local roadways, while the other used a road zipper contraflow lane. This allowed the DOT to utilize echelon paving and maintain mobility for the corridor. Setting up and removing traffic control devices such as barrels, cones, and signs is one of the most hazardous operations for work zone workers. Automation technology exists that can reduce workers' exposure to moving traffic. Separation of workers from moving traffic is critical to ensure safety for workers and motorists. To reduce exposure, there are automated technologies available to help with channelizing the traffic. Highway geometrics can also affect the overall worker safety during traffic control deployment and removal due to limited sight distance and visibility concerns. Automated access control can be used for deploying and removing traffic control for work zone lane closures with no worker exposure, and within a fraction of time taken to set up channelizing devices for the same purpose. Automation technology helps with consistent signs and device spacing and remote operation and monitoring. Automated gates offer added benefit of infrastructure to vehicle communication capable of delivering real-time warnings to motorists about road or lane closures. Such alerts can be received by motorists via mapping or navigation applications and autonomous and connected vehicles. As intelligent work zones gain traction, this feature is likely to help with automatic advance warning and likely more realistic travel time estimates. We're concluding with a photo of the Connecticut I-84 Mixmaster project. Laura and I would like to thank you all for listening. Lindsay is proud to be a part of improving safety and mobility of these projects, finding an innovative real-world solution.